and to view the webinar. So just give us just a minute more and we'll get started. So thank you. And for those of you who were with us in Providence, we really appreciate your participation. It was very well attended just a few weeks ago. Our IWCS conference was sensational in my view. I'm not trying to be biased or anything, but we had some really good panel sessions and technical presentations. Our keynote was amazing. Our executive session was really informative. But one of the panel sessions that we had this year was on sustainability and recycling, which you'll hear about more today. And it really did generate a lot of good conversation, good interest, and good input for all of us to understand. It's obviously an interesting and important topic for us going forward. So glad that we have that conversation and presentation today on that very subject. So why don't we go ahead and get started. Again, welcome to today's IWCS webinar. Good morning, good afternoon, good evening, and I know some of you are actually late into the evening, so we really appreciate your participation today. We have a few housekeeping items. And by the way, my name is Dave Cadu, and I'm the CEO of IWCS, and I'll be moderating today. But a few housekeeping items. Today, as an attendee, you're part of a wider audience, so understand that you'll be in listen-only mode. And also, we are recording this webinar event so that you and your colleagues can view it again from our website in the future as you might need. We encourage you to submit written questions to our presenters during the presentation. Please use the chat panel. It should be on the right of your screen, and type in your questions. And in the space at the bottom, be sure to hit the send button. And as the presentation is completed, your questions will be addressed at the end of the presentation. So thanks for doing that. Today we welcome Paul Brigandy, who is an applications technology leader for the Specialty Plastics Wire and Cable Group in Dow, located in Pennsylvania, USA. And also Heather Turner, who is our marketing director for Circularity and Renewable Solutions for Dow. So Paul and Heather will be presenting today their perspectives on the collaborative approaches for sustainability and sustainable cable and connectivity solutions. So Paul Brigandy is the applications technology leader for Dow Packaging and Specialty Plastics Wire and Cable business in North America, based in Collegeville, Pennsylvania, USA. Paul has experience across the cable industry and power transmission and distribution, as well as telecommunications markets, focused on research and development for new materials. His technical expertise includes formulations and processing of polyolefins, elastomers, and various polymer composites. Paul is active in several industry associations and organizations, including serving on the IWCS Symposium Committee. We thank him for being a part of this important effort, and the Insulated Conductors Committee, Communications Cable and Connectivity Association, and the Fiber Broadband Association technical committees. Paul earned his doctorate in polymer science and engineering from Lehigh University and a BS in chemical engineering from the University of Delaware. Paul is also an adjunct professor at the Lehigh University in material science and engineering. Heather joins us today as she's the North American Marketing Director for Circularity and Renewable Solutions in Dow's Packaging and Specialty Plastics business. In her role, she has responsibility to deliver the North American milestones for Dow's sustainability goals of transforming waste by driving demand for Dow's circular and renewable product offerings. Heather joined Dow in 2001 after receiving her master's in business from the Marriott School of Business at Brigham Young University, and has extensive marketing experience across various Dow businesses and innovation platforms. So again, thank you to Heather and Paul for joining us today, and appreciate the perspectives.
Thanks for having us. I'll go ahead and get started, and we look forward to sharing with you our journey at Dow and our collaboration for circular and renewable solutions. So if we go to the next slide, I just want to give a highlight of and great introduction. So I'll give a highlight of Dow now as well. If you're not familiar with our company, if you'll go to the next slide, we can talk about Dow is a very large material science company, and we thrive on bringing sustainable solutions to the industry. So we have over 45 billion sales in 2023. We're in 31 countries. What I'd like to highlight is not only all of our manufacturing sites and the various markets and technologies and chemistries that we provide to the industry, but really our innovation centers. And so we thrive on working and collaborating with our market segments that we work closely with. And so our PAC studios here in south of Houston in Freeport, Texas, are a critical development facility for us, as well as many others that we have in the US and around the world. So if you'll go to the next slide, we have very high ambitions that we can really drive our material science expertise to deliver sustainable solutions. And with that, there's three key goals that we have in our business. And the first one is to transform the waste. And so by 2030, we will sell 3 million metric tons annually and globally of circular and renewable solutions. And we're going to highlight what those product offerings are. And then also that we will close the loop. So by 2035, that 100% of the Dow resins that we sell into packaging specifically will be reusable and recyclable. And that we recognize it's so important that packages are designed for recyclability and that they are recycled. And then lastly, to protect the climate. And so by 2030, we will reduce our carbon emissions by 5 million metric tons annually, but then by 2050, we will be carbon neutral. So if you can go to the next slide, let's focus on delivering the 3 million metric tons of circular and renewable solutions. So transforming the waste. And this is where I spend so much of my time here. And so if we'll go to the next slide, we can talk about how important it is to unlock the value of waste. Now, we have a large packaging business, but we also have multiple other segments in our business unit, like wire and cable, that are so strategic for us. And so even though this ecosystem that you're looking at may be more focused, you might think on packaging because it's talking about how essential plastics are and that they get recycled. I want you to know that it's so important that recycling in general is critical. And so the feedstocks that we get through going through our ecosystem and partnering across are then inputs for recycled content, even for the wire and cable industry. And so it's just really critical that we, as a material science company, can develop resins that can be down gauged or can bring extra performance, and that can also incorporate recycled content, but that we work closely across the whole ecosystem to make sure that products are designed so they can be recycled, that they're actually captured, that we work closely with the collection and the cleaning and the sorting, that we have very high standards to the types of PCR that we can vet and we can bring in, and then that they're also then designed so they can be either mechanically or advanced recycled, and that you do the application development. We also work closely on bringing in bio-waste into this ecosystem that we'll highlight. And so it's truly a loop that needs to play, and there are a lot of partners. And so this is all about working together. It takes a village to really unlock the value of waste. So if you can go to the next slide. We also want to highlight we're a very large raw material supplier, right? And so we have been making polyethylene For years, we have process innovation in our crackers, in our catalysts, and in our high-performing resins. But things are now changing as you look at the feedstocks that come in. Not only do we use natural gas, and in other parts of the world we use naphtha, and that we're very efficient, but now we also can bring in alternative feedstocks. And so we have feedstocks that come in through mechanical recycling materials. And so something like a stretch wrap film that's come back from the retailer or from consumers, and that they can be compounded into our Revolup and other offerings. We have materials that we can have higher performance, like higher barriers, and that can be designed for recyclability in packages, and maybe replacing a nylon or EVOH, and because of the higher performance. And so it'll be mono material and it can be recycled. And then we also have from post-consumer recycling can go into advanced recycled feedstocks. And so like pyrolysis, and then that can be fed back in. And then we also have bio-waste or carbon advantaged feedstocks that also can come through. So there is more options now to really drive low carbon offerings as well as higher circular offerings. And so we really work closely with our existing assets, bringing you the high performance that you need for your markets and for your applications, but that you can incorporate recycled content or bio-waste and get enhanced properties or the performance that you're looking for, the attributes that you're looking for from a sustainability perspective. So let's go to the next slide. And as I said in that kind of busy ecosystem map that we were looking at, collaboration is critical. We can't do it all. We're not waste experts. We are plastic experts, and we know that we need to all work together. And so there are partnerships that we have, like for bio-circular feedstocks with the New Energy Blue, which will be corn stalks, corn stover taken, and that will become a bio feedstock into our process. And so that is an agreement that we have with New Energy Blue that will come online in 2027. We recently acquired a mechanical recycling producer, Circulus, to ensure that we have feedstock and that we can complement our offerings. And Paul will talk more about it. We have offtake agreements with technologies like FreePoint for pyrolysis. And then we work so closely with our industry partnerships, and so many that you participate as well. We work with the Alliance to End Plastic Waste and others to ensure that we're working together as an industry to meet the needs we have. And we work with a lot of our competitors in these as well, because we realize it's an industry concern that we all need to work together. We also recently announced a technology, a joint development agreement with P&G for dissolution. For PE, they have already taken to market through PureCycle their polypropylene offering, and so we're using their expertise and as well as ours together for polyethylene to be able to deliver another form of mechanical recycling that is very clean. And then we also work so closely with other organizations like APR and labeling and things like that on the packaging side, because designing for recyclability is such a critical part of it too. So I just highlight this, that it takes a village, that we all need to work together. So if we can go to the next slide. Just as we're positioning and people are wondering, like, what products do we use? Do we want recycled content, or do we want to lower our carbon footprint? And so we have options for both. And so if you're looking for recycled content, that's where advanced recycling or mechanical recycling fits. If you're looking for potentially lowering the greenhouse gas emissions from a carbon footprint perspective, that's where mechanical also has a really nice story, or that's where you would want to use biocircular. And so those are both offerings that we have. And so this is part of our toolbox, is that different applications, different markets have different needs, and then that we have different offerings to do, and that you can then use, and that you can bring the attributes that you need and that your customers are looking for. So if you want to go to the next slide.
Yeah, so thanks, Heather. I'll talk a little bit more about mechanical recycling from our standpoint. And kind of the first thing to highlight is the Revolup brand of products. So here we're really looking at recycled content in formulated systems. So these are single pellet, high quality, high performance type resins where we combine them then with some recycled content, where we're trying to maintain, consistent quality and product safety. We are, as was mentioned, we'll talk a little bit more, kind of always looking at the sources of recycled materials that we're using to maintain those really high reliable and recyclable materials, and then also looking at ways to be able to reduce carbon footprint in various applications. So kind of that combination of increasing circularity and recycled content while also being able to minimize your carbon footprint. So when we look at the mechanical recycling space and kind of how we get from one point to the other, I mean, again, it is really a point of collaboration, as we've said, and it's really across the chain. So working all the way back through the recyclers, so whether it's, waste management companies or, ways to kind of incorporate in industrial packaging type of things that, many of us have in our facilities, from shrink wrap and other things to that effect. It's really about how do we get those back into the stream and keep them out of landfills. And so by working closely with the recycling kind of side of things, coupling it with the material science expertise we have kind of across the company, right? I mean, I sit here talking about kind of the wire and cable side of things, but we have many other people working across the whole packaging envelope, looking at how do we analyze and characterize these resins? How do we make sure that we're delivering the best performance and properties we can? Do we need to compatibilize different types of materials? And that all feeds into what we discuss as the Revolut brand. But then even a step further, right, there's many other applications, but wire and cable is one of those where we can take advantage of these materials and start to integrate them into our ecosystem. Whether it's power cables, communication cables, there is a home for this. But we also then kind of with developing, cable solutions, it still involves a lot of the value chain to really start all talking the same language. And you heard a lot about that at IWCS a few weeks ago, particularly the Sophia Alliance, right, that is forming for this very purpose to really integrate people across the value chain and all kind of start moving in a consistent, cohesive direction for sustainability. So with that, though, I mean, one of the major things that we are conscious of and want to make sure that we do our part is really looking at the safety of these materials. So obviously we've talked about the recycle streams, various waste things that we can collect, but they in a way can be unknown compositions, right? There can be a variable set of materials or substances that may or may not come in with certain streams. And so for us, it's very important to characterize those with safety in mind. So we are very diligent about looking at the contaminant analysis, doing various forms of analytical testing and toxicology type of measures so that we are only selecting those that we feel comfortable and look at various risk profiles across various applications to make sure that we are doing our part in terms of the responsible commitment to safety when we consider recycled materials. And so that carries through all of our offerings. So as Heather mentioned, we are taking significant steps to, one, not only achieve our goals and be able to do that reliably, but also to the point of identifying and securing various streams. So we have gone through the acquisition to acquire one of the leading manufacturers of recycled content. So that being Circulus, who's got one operational plant today with another one planned to come online, and this is going to be a main source for recycling a lot of polyethylene films, very high quality output of recycled content, which then allow us to really be able to open up our toolbox to design various products for different applications, including ours. So with that, I mean, when we look at wire and cable, right, we've kind of touched on this before, but there's various ways that we can look to incorporate recycled content into various products. And this can be looking at formulated solutions. It can become a tool in a toolbox, but we can also look at things across the spectrum potentially. So not only consumer recycle, but there's ways to also incorporate industrial recycled materials. And really, as we look at including these, the conscious design area becomes in how much can you put in, and what is a trade-off between performance and recycled content, along with all the quality aspects that were mentioned. So with that, one of the newer materials for us is a Revolut grade for cable jacketing, right? So here we've got, in this case, a linear low density material, but a formulated solution with 30% recycled content in the compound. So it's a black jacketing material, which really allows for a few different things, right? So it's simpler inventory management. We kind of take the burden of bringing in the recycled content, characterizing, making sure the quality is there, putting it into a consistent, robust process to make sure that we have quality control over the outcoming material with equal or better performance to what you would expect from a traditional material, and all to increase recycled content, right? So again, it comes back to kind of what the goals are. So increasing recycled content, or in these cases, and depending on how, where it is, where it's going, some of the logistics of it, right? We can also incorporate lower CO2 emissions along the way. So with that, we'll kind of go into the bio materials now, and I'll turn it back to Heather. You're on mute. Yeah.
Thank you. Sorry. Let's talk about the biocircular offerings that we have. If you'll go to the next slide, Paul. So why would you use biocircular plastics from Dow? And so not only are these that they don't compete with food, but it really is a way to use bio waste from other industries. And so our offering today is based on used cooking oil. And then I had mentioned the partnership we have with NEB on corn stover that will be coming in a couple of years. But this is a great way to lower your carbon footprint and have the same performance. It also has a way that you have that you also can divert from fossil-based feedstocks as well. And so it really, because it's based on mass balance through ISCC Plus, these bio feedstocks are come into our crackers. And I'm going to highlight like the process that the tracking that you do for this. But because of that, then then it actually goes into our crackers, and because our manufacturing sites are so large, we don't have a dedicated line. You really do need to use the mass balance principles to be able to account for it. And so it's actually a drop-in of virgin performance. And so in that sense, like you can, any resins that you buy from Dow, we are getting all of our assets certified, and that you could actually have the bio offering for the materials you buy from us. So if you want to go to the next slide, we can talk through that a little bit more. And so ISCC Plus has a chain of custody and certification. It's used globally. We've been selling ISCC Plus based bioresins in Europe for over 5 years, and we started in the last year in North America. But it is very clear on the chain of custody, and so the feedstocks come in as a self-declaration, but each person through the value chain gets certified by ISCC Plus, and they provide what they call a sustainability declaration. And so this declaration then tells you how much quantity of the feedstock that came in, and that you track it through the system. And so with that, it's a very clean and transparent chain of custody. And that's why you also have the same performance. And so the feedstocks have the same, meet the specifications that our a naphtha or natural gas specification would be for our crackers. And then you go through in each step. So our crackers as well as our polyethylene units are certified. And then you as if you are a producer would be certified, and then the utilities or the brands that use would not need to be unless they wanted to. They could license the claims, but this would be more aligned if it was for a package or something along those lines. So it's very clean and very transparent as you go through that. And so if you want to go to the next slide. So if you're not as familiar with mass balance, you probably are. Renewable energy is widely used so mass balance is used a lot in the energy industry. And so, you get fossil fuels, you get coal, all of the different types of energy sources that go into the grid, and then you also will have renewable energy sources. And so that's how they track it through mass balance. And so this is used in other things like sustainable forestry and other agricultural programs as well. So if you'll go to the next slide. The other, one of the great value propositions for using biocircular is that you do have a much lower carbon footprint. And so we can provide a product carbon footprint, a PCF, with the grade that you purchase from Dow. But really, this is a great opportunity, especially depending on the end of life, but a really nice way to be able to lower the carbon footprint. And so if you have customers or your company is working closely on reducing their carbon emissions, especially their scope 3 goals, this would be a great opportunity to be able to contribute to lowering your greenhouse gases. If you want to go to the next slide. So let's talk about carbon, and Paul's going to take over and talk about some other offerings.
All right, so we'll go through and talk a little bit about kind of from our view protecting the climate. So you see now Dow's goals by 2030 and 2050 to really get to carbon neutrality. And so the question is how do you do that, and what are the plans? So just kind of very high level for anybody that may or may not be familiar, right? So just how the different scopes break down. Scope 1 being basically direct emissions, kind of under let's say the Dow control in this case. Scope 2 being more indirect, things we get from power that might be purchased for various operations. And then really scope 3 is anything upstream or downstream. So from our standpoint, this would be, others, but then as it feeds in, right, we would be part of others, yours, for example, scope 3. So we are looking at it kind of from all angles, as you would expect. But let's look a little bit at Dow and what we have committed to. So, we, as was said, basically have this path to zero by 2050. And so through 2020, we were basically down 15% from the baseline in 2005. And between that 2020 and 2030, we're looking at another 15% reduction. So overall 30% since 2005. And on track for that. But then it's really, how do you get to zero by 2050? All while doing it, sustainably, reliably, and also growing at the same time. So really looking at this basically site by site. Again, Heather's mentioned it a couple of times, kind of a very large corporation with many large manufacturing sites. It really boils down to a site by site approach, looking at different forms of energy to be able to power these plants, make this technology both utilizing commercially available ones, but also partnering in the right way, as you've seen, to make it a reality on things that might be newer and more innovative, and then taking these products to the market. So whether it's new products or existing products via updated approaches, I think is the key here. And so again, the efforts are really largely around all emission scopes. If you look at it, I think a couple of the key things to highlight that will start to impact this group and us in particular as we look into this space, among others, is really our drive for really reducing the carbon emissions, and one of those is a new plant that is being built, and it's basically the path to zero. And so it's going to be the first carbon neutral polyethylene plant. And so that will be important for us as we go ahead, because then this opens up the opportunities for directly providing carbon neutral materials into the market. Some cool things going on that I can't even speak to very well, but things like carbon capture, sequestration. There's a lot of things going into the ability to make such a plant net zero, along with various forms of energy, new cracking technology, many things that you can kind of read on the slide, and we can share some of this, and it's all kind of publicly available as well. But again, it really is it comes down to partnerships and collaboration, as you can see some of them on the right hand side here. One of the ones, I mean, if you were at IWCS, this was mentioned a bit, and I think you've seen it actually kind of in the news quite a bit, particularly across the communication world. Amazon just made an announcement as well. So we are actively moving forward with a collaboration with X Energy to install a modular nuclear reactor in one of our manufacturing sites on the Gulf Coast. So this is one way that we're looking at incorporating, more than 1,000 megawatts of power to our sites to make sure that we're using clean energy to make these products. And this is going to be one of those ways that by 2030, we expect this to really contribute significantly, and will also, again, kind of in turn enable our materials to be lower carbon kind of at the onset as they go into the marketplace. So just kind of highlight a couple of things that we're doing also on the product side for wire and cable. We've talked about this before, and it's really looking at ways to actually enable, right, that clean energy. So high voltage AC and DC type insulation materials, which bring, in one sense can bring renewable energy from offshore onshore. We've seen that kind of up and down, but a really necessary kind of part of the strategy for the world to kind of decarbonize and be able to electrify. So looking at both of these materials, really looking at lower carbon footprint here, designing for higher operating temperatures, and we'll highlight one of those materials here in a second. But really looking at these materials to enable power savings and really save on the carbon from our standpoint, but then also translate that down to the user. So one of those is the D4201 type high voltage insulation material, where we're really looking at maintaining all the electrical properties and mechanical properties that you would expect from an insulation, XLP insulation material with the high cleanliness, but really driving now down carbon reduction and operational efficiencies to lower the carbon footprint in the materials. So, one of the major things being the cycle time improvement, and that really comes from reduced degassing time. So, for those that are familiar or those aren't, these high voltage cables need for the byproducts to be removed. And typically that's done at elevated temperatures and really large, basically ovens to drive off byproducts. And so by designing materials that, have at least a 50 to an 80% reduction based on different cable designs, for example, you really can lower the amount of time that it takes, and thus your overall kind of energy usage for these ovens goes down, but also your productivity and ability to improve cycle times on cable production goes way up. And at the same time, for things like offshore wind farms where long lengths are required, some marine applications, we're really looking at how can you run your lines longer, faster to improve the productivity and keep them moving. So these types of materials are designed to do that, reducing scrap with less downtime, again, all with kind of carbon and greenhouse gas reduction in mind. One other example is, from a fiber optic standpoint, really looking at ways that we can help the industry move to the smaller cables, that more dense cables that everyone has been talking about and that we heard a lot about a couple weeks ago. And really, how do we do it? By maintaining all the performance that we need, right? Again, kind of those balance of performance and design, but also doing it in ways that we can be more efficient in the installs. So here we've got the 6321 type of material where we're really looking at lower coefficient of friction to be able to air jet, for example, these small micro cables into the micro ducts much faster and longer distances, but also maintaining, very good properties and even delivering better, lower shrinkage with better signal transmission quality over time. And then laser printability is another thing, kind of all coupled into one solution. So trying to also look at all the ways across the chain that we can kind of contribute to, in these cases, right, it kind of comes down into even you start thinking about civil work, and that's kind of the driver behind a lot of these applications that are being developed to result in lower carbon footprint. And then last, kind of one other thing to think about, right, is the way we're looking at, safer materials. So from a sustainability standpoint, these are also things that are important that can be considered and should be kind of developed to kind of a holistic approach, right? We've heard a lot about certain types of fluorinated materials. So looking at ways where we can kind of look at ways to eliminate those that really aren't necessarily a necessity for a given application. So that's one thing, right? We are looking continuously across the world at halogen free, low smoke type of flame retardant materials in various applications. And then even from a submarine, kind of that offshore wind farm, point of view, how can we kind of enable less use of metals, lead in particular, for ways to keep moisture out of cables? Can we tolerate it based on what we know about all of the water tree resistant materials that are in the market, for example? So how can we really look at new designs and ways to deliver differentiated solutions, all kind of coupled together with sustainability in mind? So the last slide, kind of very generic, kind of on purpose, but really the key we want to leave you with is to think about cable design for sustainability, but it's definitely not a one size fits all, right? So any various cable design can be looked at just kind of how we've had to look at, let's say, site by site. We go cable by cable, and there's various ways that you can kind of incorporate all of what you heard today, but where it makes sense, right? So you may not want to put recycled content in a very pure insulation material, for example. So that may be a good case for a bio-based material or an advanced recycle where the output is going to be the same as what a virgin material would be, but based on a different feedstock going in. The jacketing materials, yes, there's probably some trade-off there where we can incorporate recycled content, but at the same time, right, we're consistently trying to drive performance. So we're not going to just, go all the way necessarily, but with the right combinations, you can kind of put this together and start piecing kind of an optimal solution based on what you're doing, right? And so I think we would leave you with the fact that we have different tools in the toolbox to at least have the conversation and then collaborate across, right, where certain materials would be the best fit in a given application. Because again, not one size fits all. We wouldn't expect everything to go everywhere. And this is just a very rough idea, but you saw some other ideas where you can piece in different types of solutions even across this. So with that, I think that is our last slide, and we'll turn it back to Dave.
Really, really appreciate that, and the effort and the investment in this kind of technology is really going to be vital going forward. So appreciate Dow's strategies and contributions to this program. Not sure whether this is a question going backwards or going forwards, but in products, like wiring cable, but there are others as well where you have a composite of multiple materials. Is there are there efforts or capabilities for electrochemical extraction of materials, and going forward, if we have recycling or recycled content in these jackets or what have you, and then 10 years, 20 years, 40 years down the road, they are removed from service and put back into the circularity concept, will they degrade significantly to the point where they can't be reused in similar applications? You see what I'm saying? Is there a certain point where we're going backwards? There's a lot of legacy products that PVC, for example, some contain lead. How do we extract out the lead from those kinds of products, to be reused into future products? So it's a complex question, but how do we look forward to make sure that we can, we have true circularity going forward?
I mean, I can give at least my thought. I think it's a good question. I mean, at least right now for us, and Heather can correct me. I mean, I think for us, we are looking at, right, as we said, kind of characterizing anything that we're looking at. For argument's sake, if you said, okay, well, you found lead, I mean, at this point, we're not actively, well, we're probably not going to use that right now, that source. And I'm not sure, at least I don't know. We can find out, or maybe Heather can comment if we're actively looking at any ways to really clean up, if you will, those, or extract various components out. I mean, there is sorting and cleaning and all of that we do, particularly as we look at like the circulus piece. Those materials are cleaned, but I don't know about kind of that down to the low level of, chemical impurity.
Right. It's a great question, and I mean we see this in packaging as well. When you have multi-materials, it inhibits it to be recycled, and so I can only imagine with the rarity materials that you use to bring the performance you need. I do know that we have from our R&D side and across Dow businesses a lot of technology focus on how to clean, and so that could be something that we're working on more broadly, but I'm not aware of like something that we have readily available right now, but recognize that across industries, being able to not only separate and or clean so you can use the feedstock again is really critical.
Yeah, and it's an interesting conundrum, and of course when we're talking about low levels of recycled content in virgin materials, new materials, right?
Sure.
It may be in applications like wiring cable where it's limited human contact. I mean, and we're hopeful that babies won't be chewing on wiring cable, but at the same time, if you do have a very low level of bad products, whether it be lead, whether it be cadmium, and whatever, it may be okay, right? And so we may need to rethink, in a recycled circularity world, where the original concept is, hey, we don't want any lead, zero, right? Or it's limited. It may be in a new circular environment, we may need to look at, maybe that there, if you had a 10 parts per million or whatever the number may be, it might be okay. And get the true benefits of circularity. Anyway, that's appreciate the answer on that. Question is the Revolut process a closed loop? And if so, how does Dow do that?
Yes, it is not a true closed loop. A lot of the feedstocks that we use and that like through Circulus or other mechanical recyclers are film based. And so those are your stretch and your shrink films that come from the back of the store of like a retailer. All of those pallets that come in, that is very clean and has a lot of value, those films. And so it is not. Now, we as Dow do sell a lot into the market, raw materials that go into stretch and shrink film. So there's a very good chance that some of that is ours coming back, but it is not like a true closed loop where you're like collecting, directly like from a brand and then we sell right back to them and such. But it is, definitely a key, all of that should not go to the landfill, especially when it's clean and it's high performing, like stretch film or shrink film. A lot of films, have a lot of value and they're monomaterial as well. So they're really easy to recycle. And then the other comment I wanted to make even on the last question you had is, and Paul showed that slide we have about product stewardship. We work so closely with our product stewardship team. So anytime we do a qualification for a new recycler, like there's toxicology testing, there's so much testing that goes into it. And then you saw on there, on the limit of like the risk and, would it be interacting with people, food, all of that. And we even have a form that each customer has to fill out to say what application it's going into. So we're really cautious there and do work closely with our product stewardship team to do all of the testing to understand if there's any extraction, things like that that we need to be aware of.
That's excellent. Good to be aware of that. So, one of the concerns about using, Revolup or any kind of recycled content is performance. When you have multi-pass extrusions, and how do we make sure, or how do we measure, whether or not the performance has a certain limit in terms of multi-pass extrusions, and the actual question was, does the yellow index color go up after 1 to 5 Revolup extrusions?
Yeah, I mean, I can kind of comment on that. I think, from the standpoint of the question, the yellow index, I mean, it will vary. It will vary based on the materials. In some cases, right, depending on the source, your recycled material may not even be, true natural. So yeah, I think, from the standpoint of the question, though, I mean, for us, right, we're going to stand behind the quality of the material. So there's a lot of quality testing that we would do on the material themselves, but also then the final products, where, obviously if we see something, because it may be hard to know whether something has seen any other uses or recycled times or not, right? So some of that's not really going to be fully in our control, but we'll be doing, a lot of testing and stuff. There are various studies that have been done, and we could probably talk about that afterwards, where we try to look at that. But again, it's going to, in that case, it's kind of a controlled experiment versus, real world. You probably don't have that much control other than knowing what the performance requirements are for an application and testing it. But also, like you saw, like a lot of applications, maybe a black jacket is a better place for things where the color is not going to matter
Right.
as much.
Good. We have a few global friends here from different parts of the world, and one question that we have is this commercially available in the Middle East market?
Assuming the Revolup.
I assume,
I'm
yeah.
guessing. Yeah.
Yes.
Yeah. Paul, do you want to talk to that, or I can share about just our strategy in the other regions?
Yeah, I mean, you can share, and then I think the answer will be yes. I mean, globally, we're looking at the best strategies,
Sure.
with sustainability in mind, right?
Right. So we have a very active program in each region, and so because the feedstocks are regionally, you get all of your waste, your plastic waste in the region. We have regional strategies, and so I do work closely. I'm on the global team, so I do work closely with my counterparts in the other regions to develop their Revolup strategy and their product offering. And so we can connect you with our counterparts in the EMEA region that could, but with that, we also have developed different applications, and so we share our best practices and formulations with our colleagues in the other regions. So, but each region, North America, Latin America, Asia Pacific, and Europe, Middle East, Africa, all of those. Each region has a very active Revolup strategy and participation on working with mechanical PCR.
And when you measure carbon footprint and the impacts of transportation and everything, obviously regionality becomes an important component of it. But good question. Obviously the entire world is trying to contribute to better performance. So to treat the product at the end of life and for the waste stream, are there any differences versus a conventional way of handling materials? Is there anything different that should be done?
Yeah. Well, I can speak from a North America perspective. curbside recycling has been around for a long time. And so, we've got consumers that are really good at putting, their rigids, plastics and things in their curbside recycling, or participating on, more like bottles and things like that. And so it's a very fragmented, there are a lot of players when it comes to waste, as well as then working on recycled content. And so you have some large players like a waste management, WM, that do both. And then but every region, it's really fragmented. So you might have a totally different offering who picks up your trash and your waste versus the actual feedstock. So hopefully I'm answering this question, but what we see and what we're actively through our industry associations is making sure that it doesn't go to landfill, right? And so diverting plastic waste, and so whether that's through working with local MRFs, so the municipal recycling facilities, to collect additional plastics, whether it's films, or working to make sure that it's collected. And so that would be, one way is to make sure, like through conventional ways of collecting waste, that's being diverted just so it can become a feedstock. I don't know if I answered that well, but there definitely is a lot of focus on that to be able to capture it and not have it go to landfill.
No, that makes a lot of sense, Heather. Thank you. This is sort of a specific question, but for power cable insulation, and I know you talked about the cleanliness for different types of applications, but is there specific grades that you would recommend for power cable insulation?
Yeah, I mean, again, if the question's around what was shown, then that would be the D4201 materials, the new one with kind of that low emission in mind. Not sure exact question, but feel free, you can reach out.
Yeah, I think that was one of the ones that the question actually suggested, that particular grade. So anyway, thank you for doing that. So again, we want to thank Paul and Heather for contributing this great information. Just another fantastic evolution in our efforts as different industries try to understand how to manage not only capturing recycled content and the sustainability process and circularity, but also bringing the product back into these different applications. So very good information. For those of you who wish to contact Dow on this topic, I'm showing here Paul and Heather's email address, so please feel free to reach out to them directly. And also to remind you that this webinar has been recorded. We will archive this presentation. It normally takes roughly a week or so just to post it. We do have a YouTube channel as part of IWCS, and you'll be able to find it quite easily. So again, we want to thank Paul and Heather for participating and presenting today. Want to remind you that IWCS conducts technical webinars, technical paper webinars, as well as other industry leadership type of supplier spotlight webinars throughout each month. Our upcoming webinars, we have one next Tuesday, and we also have a technical presentation the week of Friday, November 15th. So coming up next week, we have two webinars. So again, we appreciate your participation, and want to remind you that we just completed our 2024 IWCS conference, Cable and Connectivity Industry Forum, but we're now in the process of formulating and designing and creating our 2025 event, which will be in Pittsburgh, Pennsylvania, in the USA at the end of October. So just want to remind you to keep your eyes open for for information on the 2025 event, but also more importantly, the call for papers. So if any of you have technologies and information that you would like to present to our global audience, please be on the lookout to submit in our call for papers. So with that, thanks again, and have a good rest of your day.
Thank you. Thanks, Dave.
Thank you.
Take care.